Assalamualaikum and good evening to my lecturer and all my fellow classmates. Today, our group 9, will be presented on Project 1, Set C, about wave locality. Before that, I will introduce all our group members. First, I will introduce myself, Muhammad Amin Saidi, as a group leader. Second, we have Muhammad Alif Naufal bin Cik Mota. Third, we have Muhammad Syahir Afiq bin Rosli. And the last one is Ahmad Isa Iskandar bin Choi Sumbok.
So I will continue our presentation and I will explain about locality of program. The locality of programs is a phenomena in which a computer program repeatedly access the same set of memory location throughout a certain time period. In other words, the locality of program refers to the computer program's proclivity to retrieve instructions with addresses that are close to one another. Loops and subroutine called in a program exemplify the property of locality of reference. Next, I will explain about types of locality. There are two types of locality. The first one is temporal locality. CPU is likely to reuse the same data object several times throughout the execution of a program. After a data object is stored into the cache on the initial miss, there are expected a lot of consecutive hits on the item. And the second one is spatial locality. If a data item is referred once, there is a good chance that its neighboring data objects will be referenced as well in the near future. Multi-data object memory blocks are common. We can anticipate the cost of duplicating a block after a miss to be amortized by future access to other objects inside that block because of spatial locality.
So my name is Muhammad Ali Naufal bin Cik Mokhtar and I'm going to presenting about importance of localities. First, the importance of locality is context awareness. Localities help systems understand local needs, culture and condition. By considering context, solution can be designed to be better, match real-world usage instead of using a one-size-fits-all approach. Second, effective implementation. When a local condition are considered, system and policies become more practical and easy to implement. This will increase the chance of success and reduce the inefficiency. Finally, equity and inclusivity. Localities help ensure fairness by recognizing difference between regions. This will allow decisions to be more inclusive and balanced. So next is wave trace result. As you guys can see, this is our configuration setup for SMP cache. Before the result, the system experienced mostly misses with 100% miss rate. This indicates a very poor cache performance before optimizing. Then we're going to look at the after result. So as you guys can see, the number of hit increased significantly to 2,828, and then the number of miss decreased to 599. Then the hit rate improved to approximately 82.5%, while the miss rate dropped to about 70.5%. This shows that the cache configuration and locality optimization greatly improve the system performance.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Isa Iskandar and now we're going to move on to discussion. So we have a few questions here. So the first one is, do all the programs have the same locality grade? The answer is no, because the programs do not have the same locality grade, which is decided by their hit rate or misses. Next, which is the program with the best locality grade? The answer is UCOM, because it has the highest hit rate at 82.00730%. Next question, which has the worst locality? The answer is SWM, because it has the lowest hit rate at 80.370%, and compared to the three traces, SWM has the highest miss rate at 19.0 CSF3243 Last question, do you think exploiting locality can improve performance? The answer is yes, because the performance of a computer is heavily dependent on the average memory access time. Now we're going to move on to result. So during the development of the experiments, you can observe graphically how in general the miss rate decreases as the execution of the program goes forward. Why? Explain the reason. As you can see, based on the three results of the traces in graphical form, the reason the misses rate decreases as the execution of the program goes forward is because at the very beginning of the graph, the miss rate spiked to nearly reach 100%. This happens because the cache is initially empty and the first few memory accesses made by the program cannot be found in the cache, so that they are guaranteed to be missed.
In conclusion, this study investigates cache performance throughout simulation-based analysis of the wave memory trace compared with the UCOM trace and the SWM trace, utilizing the SMP cache simulator. This result offers definitive evidence for the fundamental link that exists between locality and memory system performance. It also confirms that wave has very good cache performance. The comparative analysis indicates that wave performed well since it achieved a high hit rate of 82.521%, which is close to the best trace performance UCOM at 82.730%. Its difference is 0.209 percentage point. The closeness suggests that wave has strong locality characteristics similar to the optimal trace. Moreover, wave performed better than SWM by a 2.151% point difference, which corresponds to a 10.96% reduction in cache misses.